So chapter 4, day 2, we're still into kind of the preliminary stuff. Just learning how to read the parabola. What kind of information can we get by reading it? What does that information tell us about the equation? So again, we're eventually going to be graphing parabolas from various different kinds, but I'm just going to graph one here for us. We'll say that these 2 points are on it, that point, and that point. So again, I'm graphing it because I have an idea of what it looks like, but you would just see this. I'm not asking you to graph it. You're going to have a worksheet and it's going to have parabolas already graphed. Again, good habit, that would continue. But what can we read from that parabola? Well, we can tell that it's a mirror image down this line. This is not part of the parabola. That is just where it, is a reflection across that line. So that line, since it's a vertical line, it's an x line. That line happens to be at x equals 2. That's the axis of symmetry. And so we know that everything to the right corresponds to everything on the left of it. We also see something that we saw in absolute value. The vertex, in this case it's up top. The vertex on this one is 2, 1. The other important points we can read, because I used them to graph it so you kind of got the heads up, is we can read the x and y intercepts. Here we've got 3, 0 as an x-intercept. We've got 1, 0 as an x-intercept. And we've got 0, -4 as a y-intercept. As we've been graphing lines, I've been making a big deal about make sure you put those zeros in there. It's very important to match the fact that we have zeros to intercepts. Everything on the y-axis starts with a 0. Everything on the x-axis ends with a 0. So those are most of the important things. You notice it opens down, and that's going to be the same as it was for absolute value. That means a is going to be negative, and we'll talk about the details of the equation later, but that's really all I wanted to put that in there as far as what does that tell us about the equation. You could already know that a is negative. And the other thing I'm wanting you to do on these is list the maximum or minimum. This has a maximum value. It doesn't go above here. So it's got a maximum. What's the maximum value? That's why I wanted to talk about domain and range first again. The maximum value is the highest y value. Highest y value is 1. So the maximum value is 1, and that occurs when? When x equals 2. So it's going along like this. Find some appropriate tool to show you this. So it's going along like this. It gets up to this point. That's the highest point it reaches. It's the maximum. It's where x is 1. Sorry, where x is 2. The maximum is 1. And then it starts heading back down. So that's the highest point it gets to, so the maximum is 1. So, and I just want you to be able to, pick out those features. We'll talk about what to do with them later. Again, this is another one of those exercises in just building good habits so that when we go to graph, we have the habits, but also so that when we see graphs, we know what to look for. So next one here, we'll say it's got this point and this point and this point on it. Remember, they're kind of like V's with rounded bottoms. They keep getting wider and wider and wider. And when you're working on nice graphs like this, you can see I was really careful to pass that vertical line. So you can see it gets wider. Pass that vertical line. Not follow the vertical line, but pass it. So what can we pick out on this one? Well, this time our axis of symmetry is right in the middle of the coordinate plane. What's the equation of that line? A lot of people like to say y something, but vertical lines are x lines. X equals 0. That's our axis of symmetry. I'll start abbreviating. So our axis of symmetry. Do we have a y-intercept? Yep, we have a y-intercept. Do we have x-intercepts? Yep, sometimes we do and sometimes we don't. X-intercept here is 2, 0 and negative 2, 0. Now I said that 0, negative 4 is our y-intercept, but it's also our vertex on this one. So sometimes things can play double duty, right? It's a vertex and a y-intercept. So if we start talking, this one has a minimum. It goes down, stops here, and then turns around. So it's got a minimum value. Its minimum value, minimum, what's the lowest it gets to? The lowest it gets to is negative 4. When does that happen? That happens when x equals 0. Let's do an easy one. Well, if this is the graph on my grid, I can't read a y-intercept. I can't read an x-intercept. It doesn't have any x-intercepts, as a matter of fact. It never will. It will have a y-intercept eventually, but it's not in the scope of this graph, so we don't have to write it. So all we need to have is a vertex. What's my vertex? Well, let's do the axis of symmetry first. Notice the axis of symmetry is always the x value of your vertex. Axis of symmetry looks like it's negative 1, negative 2, negative 3, negative 4, negative 5. And so when I read that axis of symmetry, that is the x value of the vertex. When we have equations, that's the value we could plug in to get the y value of the vertex. So we know the x value of the vertex is negative 5, the y value is negative 2. It has a maximum because it goes up and then it turns back around. So it gets to a high point. Doesn't have a low point, it keeps going forever in that direction. So it's, let's see, maximum of negative 2. When does that negative 2 maximum happen? When x equals negative 5. Lost the second half of that slide. So let's just do one that's very skinny. Think about what makes absolute value graphs real skinny. Change in the a. Think about what kind of change in the a would make that real skinny. And I could keep graphing it going up, but I'm not going to. The point is, here's one where we're not going to have a y-intercept, but we do have an x-intercept, and we just happen to have one x-intercept. So our axis of symmetry. Again, I try to do it in a different color. We do it dashed. It's not part of the parabola. When we start grabbing parabolas, we'll graph that to help us orient it and to help us remember that, you know, that's going to be part of our vertex. Our vertex is going to be 7, 0. In this case, that's our vertex. It's also our one and only x-intercept. We don't have two x-intercepts. We don't have 0 x-intercepts. We just have one. Are we going to have a y-intercept? No. Does it have a maximum or a minimum? Well, it goes down, stops, turns around. So it has a minimum. It goes down low, but it keeps going up in both directions. You know, up this way and this way. So what's its minimum value? Well, its minimum value, where it dips down, is 0. It dips down to 0. When does it do that? When x equals 7. Now, I didn't put this on the assignment, but it wouldn't be a bad idea to practice your domain and ranges as well, but I won't make you do it as part of the assignment. So, the types of information I want you to pull from the graph, you know, what kind of intercepts did we talk about? What other things did I write down? And what does this information tell us about the equation that the parabola is representing? It's very similar to the absolute value graph. So think about, you know, mostly that was my way to start talking about the A, right? What makes the graph narrow? What makes it wide? They call that stretch and shrink. What makes that happen? What's going to be different about my A's?